Hey guys, today, for tonight's video, we're going to take a look at inequalities. Let's think about that word for a moment before we jump into what an inequality is. What does that word mean, inequality? Well, there's two parts to that word. We've got a prefix here, in. Prefix of in, right there is our prefix, in. And then we've got our root word here, equalities. So, what kind of context have you heard that prefix in before? Well, in general, if I tell you that you're inactive, what does that mean? Well, it means that you're not active. You're somebody who maybe sits around a lot. So what could that word inequalities mean? Well, it means not equal. So for the first time here, we're moving away a little bit from solving equations, and we're going to start looking at situations where we have two quantities that are not equal. And you've done this before. This is nothing new for you guys. If we think about what kinds of symbols we use to say that something is not equal, well, we're going to use symbols like these. And I'm sure that you've seen these before. And just to really quickly go over what these symbols mean, in case you don't quite remember, this is our less than symbol. It's our less than symbol. And then the one right below it is our greater than symbol. And if you have a hard time remembering which is which, just remember that this less than symbol looks a little bit like an L. I'm going to try to trace it, but my board's a little off here. Looks like an L, so we can almost write the word less out of it. That's our less than symbol, okay? And our other one, our opposite direction, is greater than. And then we have this symbol over here that looks exactly like the less than symbol, but it has that line underneath it, and that's our less than or equal to. Okay, so it's really kind of that less than symbol and an equal sign at the same time. It's our less than or equal to sign. And of course, the one right below it is our greater than or equal to sign. All right, so we're going to be working right now with some inequalities, which are going to look a lot like equations, but they're going to have these symbols in them instead of the equal sign. So let's take a look at our first inequality. We've got this guy here that says 2x plus 7 is less than 15. Remember, that's the less than symbol right there. 2x plus 7 is less than 15. Well, we're going to treat this just like an equation when it comes time to solve it. We're going to try to isolate x. So the first thing we're going to do is get rid of this plus 7 with a minus 7. And we're going to get, cancel, 2x less than 8. I'm going to divide both sides by 2, and I'm going to get that x is less than 4. Well, what does that expression mean, x is less than 4? Think about that for a minute. What does it mean if x is less than 4? Yeah, so x is less than 4 means that x could be any number smaller than 4. That's the number 3 and the number 2 and the number 1 and 0, -1, and so on and so on and so on. But it's also all the decimals and fractions in between. So we have two different ways, well, three different ways really of expressing this answer. The first one is to just write a statement like that, x is less than 4. The second way we like to express an answer like this is on a number line. So we're going to draw a number line. And right in the middle of our number line, let's draw the number that we found right there. That was 4. And we're going to put some more quantities to the right of that, like 5 and 6 and 7 on our number line. And we'll put some smaller numbers on the other end of our number line, something like that. And then we're going to graph x is less than 4. Well, think about for a moment. If x is less than 4, can x actually be 4? Well, no, it can't, right? Because if it's less than 4, it has to be something smaller than 4, not actually 4. So right on this 4, I'm going to put an open circle. Okay? And that open circle on the 4 tells me that I cannot include 4 in my answers. And then I'm going to color in all of the direction that is less than 4, and that's going to look something like this. And maybe we'll color in an arrow on that end, and we get something like that. Okay, so we're coloring in, we're showing on a graph or on a number line that all the values less than 4 are going to be true for this particular inequality. And now there's one more way that we like to write our answer here. And in order to do that, we need to think for just a moment about this number line. If I continue to go in the positive direction forever and ever and ever, I'm going to end up at the number infinity. And if I go in the negative direction forever and ever and ever, I'm going to end up at the number negative infinity. So what part is colored in here, the left half or the right half? Right, so the left half is all colored in here. So I'm coloring in everything from negative infinity all the way up to the number 4. I'm not including negative infinity because negative infinity is not an exact number. And I'm not including the number 4 because I don't get to color in that number 4. So I'm going to use that parentheses symbol. And you're going to see in a moment that there's a different symbol we use if we're including the number 4. We're not including it here, though, so we're going to use a parentheses symbol. So this reads we're going from negative infinity to 4, and that's the area that's colored in here. Let's go to another example. So we've got x over 3 minus 4 is greater than or equal to negative 2. To solve this, I'm going to start with adding 4 on both sides. I'm going to get x over 3 is greater than or equal to 2. I'm going to multiply both sides by 3. And I'm going to get x is greater than or equal to 6. We're going to go over to our number line. Right in the middle is 6. Some bigger numbers to the right, some smaller numbers to the left. In this case, I'm starting with the number 6, but my expression reads, or my inequality reads, x is greater than or equal to 6. So in this case, is x allowed to be the number 6? Yeah, of course it is. It's allowed to be 6. So what do I do there? Instead of that open circle I did in the last one, I'm going to put a closed circle. And that closed circle, that dot, represents that 6 could be an answer. And in fact, since our inequality says x is greater than or equal to 6, we're going to start with 6, and we're going to color in everything that is bigger than 6. Okay, and that is what my graph is going to look like for that particular question. All the values greater than 6. Those are the numbers like 6 and 7 and 8 and 9 and all the decimals and fractions in between. So let's think back a moment about how we're going to write the interval. All the way on the left-hand side is going to be negative infinity if I keep going and going and going. And all the way in the positive direction is going to be infinity if I keep going and going and going. So where does my coloring start? When I read this from left to right, my coloring starts on the number 6. So it's going from 6 all the way up to infinity. Again, we never include infinity, so we're going to use that parentheses symbol because infinity is not an exact number for us to say. But the number 6 this time is included. So I don't want to use the parentheses symbol because that parentheses symbol would indicate to me that I'm not allowed to use the number 6. In this case, because it's allowed to be equal, I can use the number 6. So I'm going to get rid of that symbol for a moment, and I'm going to switch to this symbol. It's a bracket. That bracket symbol indicates that we're including the number 6. So anytime we see this greater than or equal sign, we're going to notice that our dot is colored in and our interval uses a bracket. All right, let's try another example. We'll do our last example together, and then I'm going to set you to try to do a question on your own. So I need to solve this. I'm going to start by doing commutative property to combine like terms. So 2x plus 4x is 6x plus 7 less than or equal to 19. I'm going to take 7 away from both sides. I'm going to get 6x is less than or equal to 12. We'll divide both sides, and x will be less than or equal to 2. That's going to be our answer here. If x is less than or equal to 2, we're going to draw our number line with a 2 in the middle, bigger numbers beyond it, 1, 0, maybe even -1. Remember that when we're counting negatives, those numbers are going to go -1, -2, -3, etc. We're going to be less than or equal to 2. So we're going to go to the 2. Is it going to be an open circle or a closed circle on the 2 in this question? Yeah, so it's going to be a closed circle because we're including the number 2 here. Good. And then are we going to shade left or are we going to shade right? Where are the numbers that are less than 2? Perfect. It's going to be to the left here. So those are all of our numbers that are less than 2. The numbers are like 1 and 0 and negative 1, etc. When we go to do our interval here, we're going to run, remember that all the way to the left is negative infinity and all the way to the right is infinity. So our interval is going to run starting at negative infinity and going all the way up to 2. I'm going to put parentheses around the infinity because infinity is not an exact number. We can't run to that exact number. And then all the way over to 2. On 2, am I going to put a bracket or am I going to put a parentheses? Which symbol should I use around that 2? Perfect. It should have been a bracket because it's allowed to equal the number 2. All right, so we're going to go to one last question here, and I want you to try to answer this question by yourself. And then I'll explain it towards the end of the video, and we'll make sure that everything was going well for you. And if you have any additional questions, of course, bring them with you to class tomorrow, and we will start talking about inequalities in class tomorrow. So here's our last question. Here's your turn. Give it a try. So what we should have done is our first step should have been to distribute. And we're going to get 6x plus 3 plus 4x is greater than 53. We'll combine our like terms and get 10x plus 3 is greater than 53. We'll take away 3 on both sides, and we'll get 10x is greater than 50. And then we'll divide by 10. And we're going to get x is greater than 5. Now let's take a look really quickly at how we would graph that. So if you haven't already graphed it, I'm going to ask you to take a pause right now, and I want you to put that on a number line, and I want you to try to write the interval. Good, so let's see if you did that right. Our number line is going to look something like this. 5 in the middle, bigger numbers to the right, smaller numbers to the left. We're going to put a circle on 5. We are not going to shade it in because it says greater than 5. It doesn't say greater than or equal to. So we're going to leave it open, and we're going to color in everything bigger than 5. Okay, something like that. And then if we want to write our interval, remember that negative infinity is over here and infinity is over here. So as I'm reading from left to right, the first thing that I see that's colored in is 5, and it goes from 5 all the way to infinity. Infinity always gets a parentheses because it's not an exact number. And 5 here is going to get also a parentheses because we're not including the number 5. Okay? So our takeaways from this lesson, a couple things that I want you to make sure that you're comfortable with. We're still solving these the exact same way that we were solving equations for the last couple of weeks, so that should not be too different for you. The two things that are really the difference here is we want to get comfortable graphing on a number line. So make sure that you feel good about graphing on the number line. And then we want to be able to turn our number line into an interval. We want to be able to write this as an interval as well as a number line. So make sure you feel comfortable with those things. If you need to go back and review anything before tomorrow, feel free to do so. And if not, I will see you guys in class tomorrow, and we'll take care of it then. See you later.